Sorry for that. So as I was saying, I'm Francesco Frassinelli, and this is a thesis where I try to move a little bit further with respect to the evaluation of OpenStreetMap intrinsic temporal accuracy and evaluate up-to-dateness of historical data in OpenStreetMap. So OpenStreetMap, maybe you are used to see this kind of website, OpenStreetMap.org, but this is not just a map, it's a spatial database that can be rendered in different ways. And it can be also analyzed by researchers to run analysis, and it's more like a wiki, like Wikipedia, but for maps, if you are. Yeah. So, a few words about the data model. So we have physical object, and then we have the representation in the database. So in OpenStreetMap, we talk about node when we talk about points, and those points can be things that are very small as an area, so it makes sense to use points, and they stand by themselves, like charging facilities for electric vehicles, so it's like a pole. And then we have some tags, which are one or more tags are represented by a key value list that represent the described letter with different degrees of accuracy. Then we have ways that are composed, and they are made by an ordered list of points, of nodes, like be a railway, a path, but they can be also closed. So the last point match the first one, that means that we have an area. It can be a building, a playground, it has some other attributes, and then we have a relation, which is something slightly more complicated. That means, for example, we can express that from a specific road we cannot go into another specific road, so it's kind of a restriction, but it's also used to express for example, buildings that have an inner area, like maybe a square or playground, and then you have the building itself. So inner and outer relations. OpenStreetMap, it's widely popular. I started contributing to in 2008, and there were a lot of roads missing, and many details were missing. Nowadays, it has 8 million registered users, 7 billion unique nodes, 800 million ways. I mean, it's now a successful project. And it's interesting because, of course, it's the most successful crowdsourced spatial database. It's released under an open source like license, but for database, so for data. But the interesting thing for us is that the history is available through database exports, so it means files, very big files, or as a web service, so API, so we can query based on our needs some specific areas. What's the problem here is that it's crowdsourced, so we don't have a quality that is kind of stable across all the areas and countries and such, because it's crowdsourced. So we want to estimate the quality, because if we don't have an idea about the quality, it's hard to use the data. And but there are different possible criteria. We can think about spatial accuracies. So if a building has been placed correctly, or maybe within a 10-meter server, it's important to know that. Or consistency, semantic consistency, like proper tagging, and temporal completeness. That means that the evolution of, for example, a shop, maybe change the name or time. Then we have this kind of evolution represented correctly in an accurate manner in the database itself. So we have two families of approaches. The first one is extrinsic, which means that we are comparing OpenStreetMap with an external source that is official, and maybe it comes from an funding institution in this case. But the problem is that even official maps maybe are not up to date with very recent changes. And then we have intrinsic way, that means compare OpenStreetMap to itself, or maybe to the guidelines that we have in OpenStreetMap Wiki. For example, maybe you shouldn't use a tag together with something else. And what's the goal of this thesis? Is to evaluate the feasibility of using OpenStreetMap for estimating intrinsic temporal accuracy with limited resources. We are not even going to use clusters and such. See if there are other softwares that we can use, or libraries, or frameworks, whatsoever. Make a new one, or maybe improve the existing one, maybe move. And then figure out what's the road ahead, like in this research environment, what can we do next. So in 2018, I shared some preliminary results on feasibility at different conferences, national and international conferences. And what I produced, I took 7 different indexes, but I explored 2 paths actually. So the first one was to go with some custom scripts to convert the data into a database that is usable, not like a zip file of very highly compressed data, but something that can be accessed. So it was partially automated using the planet history file. That means having the whole OpenStreetMap database to as file and then cutting it on a specific region like Italy. And then, of course, it's not user-friendly, like it's a Python script with some bash and such. And then the storage needed is more than 100 gigabytes because the planet file is more than 100 gigabytes, then you need to cut it, and that requires hours. But it's good because you can, as you work with a lot of data and you have no kind of time constraint, you can work on big areas, and then you can also aggregate data together to have something nice. But then I told myself it would be nice to have it as a service, so I developed a web application to explore the data, which is nice because I was fully automated, kind of user-friendly, not much storage is needed because we fetch data from the OpenStreetMap API only when we need it, but the array was very small. And then we cannot aggregate data because there is not enough data to aggregate. So of course I computed very different indexes on Italy, on the whole Italy, contributor per square kilometer, up-to-date frequency on Milan using a different grid, hexagonal grid, which is better. I found some trends, we are not going to discuss about it. And then we had a conference paper for Phosphorus conference in Dar es Salaam with the last edit. Again, we see some trends there. But then, and this is the application running from 2018, actually. This is version 1.4. So you can see the lines and the ways and the points that are colored based on a criteria that is being chosen. This is update frequency. And you can see, like, from legend, the scale, and zoom around and move around. But this is a low. They're working on 1-2 square kilometers actually. And then in 2019, I co-authored a paper with Marco Maghini, and we tried to figure out more like research appropriate way with like better method. What's out there in terms of research, what has been studied, and also in terms of what's the software. This is a long list. It was quite extensive review about frameworks, applications, scripts, and tools, and APIs, and such. And now today I have 35 different citations from also conference papers and reports, etc. So there is some interest in this field, actually. And then I wasn't totally satisfied with my work, my thesis, because then I said, yeah, we have 2 different methods, but it would be nice to have a web service that can work on big areas, but in the web and computing in a few seconds, and also maybe have data aggregation. And that has been the biggest challenge in this thesis with respect to data processing. So what happened in the meanwhile from the end of 2019 till today? 300 commits later, that means 300 software revisions later, hundreds of hours, and thousands of code of line change. We had performance improvement, so it's been nice because I started to see from zooming out, I'm able to compute, zooming out again, and try to optimize step by step. So we have pretty nice file data caching. That means that we are not fetching a specific bounding box and then store it, because every user has a different request, but we try to split the map into a grid. And then if the user requests a bounding box, we take all the tiles that includes this bounding box, so we are fetching more data, and then make it powerful, because then it's easier to reuse. And then we also use quite big tiles, because if we request very small tiles multiple times, we have a kind of performance penalty, because it doesn't, if I get a tile that is 4 times larger, the size is, the time needed is just twice, it's not 4 times, so it doesn't progress linearly. We have this Redis database that is great for caching validation and such, data pipelining, which means that instead of fetching the data, storing, processing, and sending, we are processing the data while we are downloading them, and we are sending to the browser while we are processing it. So we are trying to do as fast as possible. I'm using OSM APIs instead of the official OSM APIs that are not really meant for big data statistics. Also, they upgraded their servers in the summer of 2020. That has been the game changer for me because I tried again because I told myself, no, there should be a better method. I brought it to the Heidelberg researchers. They upgraded the server, so it was possible. Massive parallelization. We have cloud auto-scaling. That means that if we have many users, the system will automatically start again a new server, install the software, and automatically do load balancing to this kind of techniques. And then we also have new feature improvement. We finally have clustering, so we can aggregate the data together based on different criteria, automated testings for regressions, and then all the things that we can think about to have allow people, this is an open source software, to contribute and kind of reduce the level of difficulties to send new commits and statistics. You can know the statistics. We have QGIS integration, so you can use other softwares, and the software overall is a bit more stable. This is stored on GitHub, and the service has been running from 2018 now. We have almost 400 commits, 12 releases, 17 people get updates on every new release because they are interested in this kind of thing. So that's the result. It's not everything green, but we got a decent result. So we can work, perhaps not as fast as I want because it still require maybe 30-60 seconds depending on the size. This is how the software looks like. This is where we are having the thesis today. So with the points and the clusters and the criteria, and then you can have the filters or set some boundaries. Those are the 4 criteria that I use. You can click a node and then you get redirected to the OpenStreetMap wiki to get information. What does it mean covered? And then you can edit the node, you have the history, you have the details. And then you have what they call tiles, which is this is a raster that is generated. This is a PNG image. And that works pretty well in my opinion to represent the data. But of course, maybe in some areas you get a lot of very up-to-date, for example, data, and then everything is yellow. So you can use a different aggregating methodology. You can use different quantiles, minimum and maximum, so to be able to spot the difference in certain areas. But the software itself will always try to set minimum and maximum according to the bounding box that you are analyzing. You have some statistics, and then you can download the statistics and download the file as GeoJSON, which is a standard for representing spatial information. And then you can also set some boundaries, like this is a Milano boundaries, and then you can select all the shops that we have in Milano. So restrict your area because you just are interested in those kind of things, not in the whole bounding box. I did a survey, 23 people replied, most of them are contributors, some of them have also an academic background, or researchers. Those are the scores of the various features. Maybe the not so great one was the processing speed, but I have to tell that 2 people actually couldn't use the software because there was some downtime here. So with respect to the performances, that was pretty hard, tough thing. If the data is cached, it's very fast for the whole city of Milan. So it's a few 100,000 nodes. And we have 5 seconds, depending if you want to get statistic, if you want to get the full data, or just a raster. If it's not cached, you can wait a minute. That's the speed. And most of them found it useful, would like to use again, maybe with some improvements. Of course, there are still some glitches. Future work, I couldn't get an overall quality index. That's more like a research topic that we should move forward. But I hope that this software could help a bit for the researcher as starting point. We have more feature, improve usability. Some user couldn't find the search function, but it's there. And then export like georeferenced and raster, get some better performance and talk about the thesis. And then of course there are things that are out of our reach, like having a higher availability for the awesome servers, but this is university servers and it's out of our reach. There are some researchers on that. Last announcement, that's a nice news. I got an email from Heidelberg and they wrote me because they noticed that my software was the biggest software using their service. We have 100 monthly users. Not all of them are related to the survey, I noticed, because there are some backlinks from some French forums and such. And so there will be published a brief interview about this software soon. Is there any question?
Peter moving online. Maybe, Peter, can you hear us? I don't know if you have questions. Why I asked also you if you have questions.
What kind of hardware are you using? What is the PC or the smartphone? Is it a problem? Can you gain something if you double the speed of the CPU?
Yeah, that's an interesting question, because I work on trying to reduce the performance requirement as much as possible. So I'm using a 256 megabyte of RAM in a virtual private server. That means basically €5 per month, so I can maintain it, and with the whole operating system, not just the software. But the problem is that even if I allocate more memory, actually it can be only useful for the cache, because I'm going to cache more data, but it will not process much faster, because the overhead of the software itself now it's limited, as you can see from the performance with respect to producing the raster. If the data is cached, it's just 1 second for the whole city of Milan.
Yeah, another question. Is it parallel? You can do parallel processes?
Yeah, this is, so I use 5 different Python frameworks to figure out what was the best to have massive processing, especially for raster, because you have to produce many different PNG files to produce this bigger raster. So you are able to produce 100 or 1,000 code design function 100 or 1,000 of time in parallel. This is why we have auto-scaling. So you can have 2 services running in 2 different data centers, and you just need 1 single database as cache, and you don't have locking issues. You have concurrency on multi-node, multi-processing, and multi-threading.
What is the minimum hardware requirement?
You just need, I would say, 256 megabyte of RAM, including the Linux operating system with a small instance. And then I decide for performance improvement and to be able to auto-scale, to set up an external Redis database. So you just have a Redis cluster or a single one. So you have 2 virtual machines with 256 for the main software and from 124 for the database megabyte.
I see Peter Mune again.
Peter, can you hear us?
Maybe he cannot. Oh.
Yes, I can hear you.
Okay. So if you have questions, please.
So
Yeah,
Peter.
Thank you, Francesco, for a really nice presentation. My only question really is, have you any sense of the applications users are using this service for, given that it is reasonably popular amongst the users? So what type of research or applications are they using it for?
Yeah, that's a good question. I wrote in a bit on the thesis, but I also get some feedback afterward. I printed it, and it's pretty interesting because this is an application that is used. I've seen by the Italian open source, the Italian OpenStreetMap community, but also a bit from the French one. I discovered that someone suggested it on a forum on OpenStreetMap.fr, and they are doing more for like gardening of the data. So the spot maybe outliers and this data it seems unusual. It's not up to date. So you have this kind of OpenStreetMap contributors, and then I got a mail. From a South African university, and then the professor said, oh, that could be really interesting for my students to evaluate some areas and to do some maybe to start reasoning about intrinsic quality. So, and that's it. I haven't, let's say, advertised the software a lot until now because I wanted to work a bit further, and that's it. So. But the researcher side, from an numerical perspective, is like a minority in the assets that I see. It's mostly OSM contributors. Like the ratio looks to me like it's 90% to 10%, but maybe in the future with more researcher could start from this software. That's my hope at least. Because you don't have maybe to have a powerful computer to explore the data just to have a sense of what's happening, and then this is not computing a quality index at the end, but gives you some indexes that can act as suggestion. You download the data, and then you can compute and weight the data based on what you want. Maybe tags, maybe a special correlation and such.
And just on last question on the quality index. What's your feeling about the next step towards a quality index where this temporal aspect is a very important component of that overall index?
Yeah, for sure, tagging is crucial because, of course, having a bench will not change over time, but a shop will change probably more often. There is actually, I've seen in the OpenStreetMap community that some users started to add an additional tag just to say, I checked this feature. Even if they don't change kind of the type of the shop, they just pass by and they say that this shop has the same name, has the same phone number, and that's useful. There are some smartphone applications that suggest to the user, please, could you please check this area because it hasn't been checked for a while. So that could be useful. But just one node over, we have 0.1% of the tags of the nodes in OpenStreetMap have this tag. But this straight compute application is very popular, so hopefully we can rely on that a bit more. But then I see that there is a huge difference between different cities, because you have different mappers, and mappers are interested in different things, different mapping type. But also inside the same area, I've seen in Milan, there are the most famous roads for shopping, and they have a very high temporal accuracy, in my opinion, for what I've seen. So we really need to reason in terms, I think, of being able to discriminate between different areas. So we should really focus on spatial correlation and being able to discriminate at a very high resolution this kind of local points. Even more than tagging that can be, we wouldn't say trivial, but reasonable.
Okay, that's great. Thank you very much. That's very informative. Thank you.
Thanks to you.
Thank you. Okay.
Okay, thank you.
Thank you.